In any modern platform and infrastructure today, it is rarely the case where we deploy a pod in the Kubernetes and we do not send API requests to outside the cluster. We usually require the pod to talk to external services, whether to store the backups in AWS S3, whether to fetch the secrets from Azure Vault, or whether to just basically do any kind of request outside the cluster to other service providers. So in today's video, I'm gonna provide a guide on how to grant pods of a Kubernetes cluster access to the external services without the need to pass credentials, the client ID, client secret, usually is what is called, or service principal in Azure. So this can be a bit tricky sometimes. Basically, the understanding of this whole concept can be a bit tricky, and so that's why before jumping into the code, I would like to provide a solid understanding of the fundamentals involved around this concept, which is called OpenID Connect. So as I mentioned, there's going to be a need for the pod to talk to outside services. However, we cannot open those service providers without authentication. We cannot just expose them to the internet without authentication. That's why the authentication is required. However, we want also the pod, the trusted pod that we know of, to be able to still contact the service provider. So the way we do that is actually, a bit after you understand this whole concept, it's going to become so much easier. But for now, there's going to be three actors involved. One of them is the pod, which is for us, and in this example, in today's code, it's going to be external secret operator. This pod over here, this external secret operator, wants to access the secrets stored in Azure Vault and mount them as Kubernetes secret inside the cluster. So how do we do that without passing any credential into the pod? The way we do that is using the identity provider, which is the Kubernetes API server. We establish a trust relationship between the Kubernetes API server and the service provider over here. And with this trust relationship, every time the pod runs, it is going to have that service account token inside as a volume mounted, the JWT token mounted inside the pod. And then when it is going to send the API request to Azure asking for a specific secret, it's going to include that token in its request. The token will be validated using the public key of the API server. And with that validation, if it has been successful, this request is granted and the resource will be fetched by this pod. Otherwise, there's going to be a 401 unauthenticated or 403 forbidden in either case. One important thing to mention here is that the name here, like identity provider and the service provider. Service provider is named the way it does because it is providing a service. It is providing, like in the case of Azure Key Vault, it is providing secrets services. You store secret, you get services, you list them. That's what you do with the service provider. You ask them a specific type of service. Why do we name Kubernetes API server the identity provider? Well, the idea is that every time the API server is going to schedule a pod on a worker node, it is going to assign an identity to the pod. It is going to say, this is pod external secrets, and it has been deployed in namespace external secret, for example. And so with that identity, that's like the identity attached to this pod. And so that's why this API server is called the identity provider, because it is providing an identity to the pod. With that identity, the pod can get the token, get the JWT token that is mapped to that identity and send requests. So that's basically the idea of why these are named the way they do. Identity provider is providing some identity to the pod, and service provider is providing some services behind some authentication in this case. But that's basically the idea. Another thing to mention here is that the Kubernetes cluster that we're talking here is no magic Kubernetes cluster. Like, this can be any type of Kubernetes that you have. It can be Minikube, K3D, K3S. It can be a Kubernetes cluster bootstrapped with Kube ADM. It can be an Azure AKS managed cluster. It can be a AWS EKS cluster. It works either way. Like, you can take this idea, you can apply this to your Kubernetes cluster for any use case that you require. The thing that you're going to cover today can be applied pretty neat in most of the things that you need to pass credentials for. And so the requirement here is that the service provider, the main requirement here is that service provider and the identity provider both need to support OpenID Connect. If one of them does not support that, and then you cannot have this and apply this idea, because that's the basic requirement here. Identity provider and the service provider will both require to support OpenID Connect, which, as I mentioned earlier, most of the modern infrastructure support that already out of the box. And that's pretty neat, because you can apply this many places, not just Kubernetes cluster. So let us take this idea, take this diagram, write some code, and then we understand what's going on. But before we do that, and before we jump into the code, I'm going to emphasize the agenda that we're going to cover here. So there's going to be a couple of stacks we're going to write, and they're all going to be written with TF files, Terraform or OpenTofu, whichever you prefer. I'm going to be using OpenTofu for this project, but I'm going to be calling it TF. So the first stack that we're going to be creating is GitHub repository, and I'm going to tell you why. So you recall that we were creating we were establishing a trust relationship. This trust relationship comes in the form of identity provider exposing a specific endpoint out to the internet publicly and behind the HTTPS. These are the requirements. First, the HTTPS part, and then this URI over here. It has to be exactly what you see right here on the screen. A well-known OpenID configuration. As soon as the API server is able to expose its OpenID configuration through this endpoint, and then any service provider that supports OpenID Connect can trust this identity provider. We're going to be basically using a public GitHub repository, deploying our OpenID configuration as well as the public keys inside that GitHub repository. Use the feature of GitHub Pages to serve static files, and with that static files, any service provider can then be sending these requests and then fetching the values that is present on that GitHub repository, which is coming from the Kubernetes API server, by the way. We're going to cover all of that, but this is the main idea of creating a GitHub repository and storing the OpenID configuration of that Kubernetes in a GitHub repository and serving them as GitHub pages. So that's basically the reason we are going to be doing, we're going to be creating GitHub repository at first. Then there's going to be a deploy key with the write permission. Deploy keys are SSH private keys and public keys that you generate on your machine, basically, and then they will be able to talk to GitHub API, clone the repository, and in case you granted the write permission, it will be able to even write to the repository. So let's cover the first one, and then we'll get back to the rest of this stack later on. All right, I'm finally in my editor, and the first stack that I would like to create is a GitHub repository that will hold my OpenID configuration, and using GitHub Pages, I will serve those as static files to the public and accessible through the internet, basically. So there's a couple of files that I'm going to create, but let's start with the main TF first. My first resource that I will be creating is a GitHub repository, and I name most of my resources this, unless there's a conflict, and then I will rename them accordingly. The name of it is going to be Kubernetes OpenID configuration, as well as visibility, which is going to be public. there's going to be vulnerability scan because that is available on my organization, and if I don't create this right here, it will later show me as a change resource. Auto init is true, and of course I'm gonna need a home page URL. This is gonna be in the form of HTTPS GitHub owner and then github.io. Later it's going to be GitHub repository. So that's where I will be using the name of my account, which means I'm going to need the variables.tf and then variable here GitHub owner, and it's going to be of type string. The default is developer friendly, of course. When I come back here again, I will have access to that GitHub owner and github.io. Later it's going to be the name of this repository right here. I'm going to copy that, paste it here, and that's pretty much it. There's going to be a pages block over here, build type. There are two types of build. I will be using the workflow. There's also the branch type. The source is going to be branch main, and the path is going to be slash. Okay, this will create my GitHub repository, but before doing that, I do use Terragrunt, which means I need to create a Terragrunt.html over here, and the inputs right now are basically empty, but I will keep this block for later use, and I can define my dependencies here, as you will see later on in later stacks, and that should be it. But there's also the versions.tf. I will require to have required providers of GitHub, and it's going to be source of GitHub integrations GitHub, and version, if you don't specify, it's going to grab the latest. So for me it's going to be 6.2. required version is no longer required right now, but let's just say the provider of GitHub is going to be owner var.github owner. So let's apply that terminal. All right, in the terminal now I have access to the directory I just created. If I go into the gh repo and I say these are the files, so something I would like to do to make my life easier is to create just a just file over here that will allow me to have universal commands across every directory over here. So there's going to be a cd, no cd here, init Terragrunt init upgrade. There's going to be another one, plan Terragrunt plan dash out tf plan. Using the same technique, this time apply, and now I have it. I would like to also have fmt sometimes, so that will allow me to say tofu fmt write recursive, as well as Terragrunt run all htfmt Terragrunt non-interactive. Okay, that should be it for me. Here we are again, just init. It will grab the GitHub integrations from Terraform registry, or in this case Tofu registry actually, and then I will be able to say just plan. Visibility, there's a typo. All right, one resource to add, that should be my GitHub repository right here. Excellent, just apply. So as you see, the repository has been created. I can just get inside, initial commit just now. There is a action happening which will most likely fail, but never mind. Let's get back to the editor. Okay. Okay, back to the editor. It is now time to create a SSH deploy key. So we will create TLS private key. This is the name of the resource. Algorithm, as far as I am concerned, ED25 519 is the best, but I have seen limited support for that in GitHub. So I'm gonna use the RSA over here. There's gonna be two more resources right now. GitHub repository deploy key with the name of this. Title is Kubernetes deploy key, as well as repository, which is going to be GitHub repository, and its name. Key is going to be TLS private key. That this private key public key OpenSSH. Yes, this one. And it will not be read only. So read only is false. Link it. Going back to the second, the last resource in this stack. This is going to be GitHub repository file. And this is also going to be a this. This one will be the same as before, same repository, branch main, file, GitHub workloads, ci.yaml. So what I'm doing right now is, after creating the deploy key in these two resources, I'm also gonna need a ci.yaml definition, which I can already do outside TF and using terminal git clone and add the file and git init, commit and everything, git push. But I'm just doing that over here. It's just gonna be so much easier for me to manage because everything is gonna be inside TF files. As you will see, I will rarely leave the TF files, and this will give me more flexibility into the input, the output, and how I'm gonna coordinate between my stacks. The content is gonna be file of, well, here path.module. After that, there's gonna be files ci.yaml. The commit message is going to be fit at initial CI definition, workflow definition. Commit author is going to be my name, commit email, and lastly, overwrite and create, which is false. So that is pretty much it, everything that you need to create over here. Back to the terminal again, just plan. I did have another resource, so just init, because there's going to be a TLS added here again. As you can see, latest version. Just plan, path module is missing. That means I don't have my CI definition just yet, which I'm going to create right away. And there is a file here, ci.yaml. I will basically copy paste this, but let me explain this real quick. So this is the name of it. I do want to cancel the concurrent runs if it does happen. And this is the triggers, one to the every push to the main, the other one is the manual runs. And these are the permissions. I will need a content read because I'm gonna publish the content of the main branch to the GitHub pages. The pages require a write permission as well as the ID token, which is another instance of OpenID Connect coming into action, but this time it's all happening inside GitHub. So the GitHub runner will get a token from GitHub Actions. Using that token, it will try to write the contents to the pages. So it will provide that token when talking to GitHub Pages API. The normal workflow is as follows. So basically check out, set up pages as usual, upload the artifact. We don't necessarily, oh, I think we do need to have to. So we need these two steps to grab all the content of the current directory and push them to GitHub Pages. So as soon as this happens, everything inside the main branch will be published to GitHub Pages. Everything includes the root directory. Back to terminal again and apply this stack. So as you can see, there are 3 resources to be added: TLS private key, the CI file, which is going to be a commit, by the way, and the deploy key. Just apply. Excellent. 3 resources have been added. Let's check the repository. Okay, back to the repository here, settings, deploy keys. As you can see, this has just been added with read and write permission, never used, authenticated by GitHub CLI, because my terminal is authenticated using the GHCLI, and with that authentication I am allowed to run TF commands against the GitHub API. And this is my username over here, so it's all good. Let's get back to the second objective now. Okay, we have done the first part. Now we have the GitHub repository, we have the GitHub deploy key with the write permission, and so with this setup we will be able to get to the next step, which is optionally create a GPG key and add it to the user GPG keys. So essentially this will allow me to have commits from inside my Kubernetes clusters pod to this repository over here to be all signed. So if I go here right now, you can see that the first commit has been verified because it has been a command of creating a new repository, and with auto init true, this will have my email and the GPG key assigned to it. So basically it's already verified. But the second one was a normal commit without any sign, without any GPG sign, which means this is already unverified. I don't want to have this on my repository, which means I do like to have that GPG created. So let's get to the editor, create the GPG key and add it to my user. All right, I'm here in my editor. I will remove all of these and I will create another one. This is going to be user GPG keys. The first file that I will be creating is another versions.tf. Since this is going to be a talk to a request to GitHub API, I will require a GitHub provider over here. So let me just grab this here. I will also require the GitHub owner variable. So let me grab that one as well. And I'm gonna have this, but this time I'm gonna provide my own username, because having GPG key on the organization is not is it undefined behavior. So far you can only have GPG keys on your own username with your email and everything, so that's not possible on the organization right now. Let's get to the main to create the resources over there. The first resource that we'll be creating is GPG private key, and the name of it is going to be this. The name of this GPG key is the name of you, basically. So this can be any name that you want to assign this. And then the name of it, the email is the email that you will be using to commit to the repository, which has to be the same. Otherwise, the verified tag or badge is not going to be applied on the commit. Passphrase is going to be null, because I don't want passphrase on this. This is on my Terraform and it's already encrypted with TF Tofu version 1.8 onwards. RSA bits, I could have leave it as default, but let's just specify that. And lastly, this is going to be GitHub user GPG key. The name is this, and let's see, there's going to be armored public key, and that is going to be GPG key dot this dot public key. There's also going to be output here, because I will need the output of this stack to be used elsewhere. Output GPG private key value GPG private key this, and then this is going to be private key, but this is sensitive, so I don't want it to be just printed out. That's gotta be it. There's also a Terragrunt that needs to happen over here. I'm just gonna copy it and paste it here. As soon as I have this, I'm ready to apply this stack. So I'm gonna go back to my terminal. Okay, back to the terminal now. I'm gonna go to this user GPG key, just in it, same story as before, getting the providers. By the way, I do not like this GPG. I'm gonna get another one, versions.tf. So GPG is gonna be, for me, the source is Oliver GPG version 0.2. And now I should be able to say init, getting the other GPG provider. Okay, init has been successful, just plan. There is an issue here, which means I gotta get back to supported attribute. Private key on GitHub user is not supported. So this is the output. I'm gonna use this one instead. Back here again, just plan. Excellent. 2 new to add, 1 output. This should all be good. Just apply. GPG key has been created, and as well as that, there's also a GitHub user GPG key which has been created. Excellent. So now that I have this, I'm able to continue with my next stack. All right, we are here and we are on a roll. We're gonna create an spin up our cluster, and by doing that, we will have to customize the Kubernetes API server flag for issue URL as well as the JW cause URL. We want those values to point to the GitHub pages. So otherwise, it would just be like a local host something. And that's not what you want, because we want the API server to point its OpenID configuration to the place that we are storing our static files for OpenID configuration. So let's go ahead and do that. But before jumping into this, the reason that we are going through all these trouble so far, 3 steps, repository key, deploy key, GPG key, is that the Kubernetes cluster that we are creating here right now is K3D, and it's spinning up on our own local host, which means it is not internet accessible unless using other tools like ngrok. That requires me to expose its OpenID configuration elsewhere. So GitHub Pages is that place for me to just store my public key and OpenID configuration so that other people can trust my Kubernetes cluster using the protocol of OpenID Connect. Let's get back to the editor and spin out the Kubernetes cluster and modify its issuer URL and see how that is going to help us into the next step. Okay, back to the editor again, and now let's create the Kubernetes cluster this time. The first thing that we're going to require is a main.tf. In this main.tf file, I'm going to need to grab my K3D config, which I'll be writing in a sec. Template file. The path is going to be path.module templates k3d config.yaml.tftpl, and the value of it is going to be issuer URL is another variable of issuer URL, which I'll be creating in a sec. Let's get back to here, variables .tf, issuer URL, type is a string, nullable is false. And I have this right now. I will be creating K3D as well. This is going to be templates, the value, Inside there's going to be a file config.yaml.tf.tpl. This is going to be language YAML for me to see the syntax highlighting, but when I get to the file, this is going to be API version. Actually, this is going to be a long file. Let me just grab this real quick from here. So this is the file right now. The API version, kind simple, metadata Kubernetes. I only require one node. This is not a production one. The image, I specified that already. This is my Kubernetes version. When all is ready, and I need to specify two Kubernetes API server arguments here. One, service account issuer URL, which is going to be HTTPS and the GitHub Pages URL we created in our initial stack. And the next argument that I'm customizing here is going to be the same variable as before, but this time there will be additional URI attached to it. So in the end, what's going to happen is that this variable will be in this form, which is going to be, let me just comment this out, HTTPS, and so my GitHub owner username, which was developer friendly at the time, and then github.io, and then the name of the repository, which is Kubernetes OpenID configuration. So this is going to be over here, and then the next one, which is going to be just about similar, except for the fact that this is going to be one URI different from the last one, GWCause, and that's basically it. Using this configuration, I'll be able to spin up my Kubernetes cluster using K3D. Back to the main file now, and now the rest of this file will require me to create that file, that configuration file. So it's going to be a resource local file, and the name of it, which is going to be K3D config. Here we go. Content is going to be local.k3d config, and file name. I need an ephemeral place here. I really don't care to persist this, so this is going to be passed at root and Terraform tmp some random value, but let's just keep it as a timestamp dot YAML, because I do have a YAML definition in there. File permission, this is my file permission, and that's pretty much it. I just want to get to the next part now. Resource, which is creating the Kubernetes cluster after all this configuration, and now it's going to be provisioner of local. The command is K3D, and by the way, running this TF file on my local machine requires K3D to be installed, which is already the case. But if you do not, you're just going to have to get to the repository and install it. Cluster create -c local file dot K3D, and the name of it, which is going to be file name. So that gives me quite about everything I need to create my cluster on my local machine. Let me just briefly create an output .tf K3D config just to have a visual. Value is well, local K3D config, and so that's pretty much everything I need from this stack. Let's get to the terminal and apply this. Okay, back to the terminal now. Let's go to a Kubernetes cluster, just init, business as usual, no such file or directory. We don't have Terragrunt, no worries. We will grab this one. Just init, just plan. Okay, this is a great time to get back to our dependency. Here we are again. you remember that we had an output here, or maybe not. I'm just going to create that right away. There's going to be a GitHub repository. So output GitHub Pages URL, value is this dude, and the home page URL. This is the value that I require, and when I get back to my Kubernetes cluster, I will be able to say there is a dependency on the GH repo, and it is coming from GH repo. So you see, I'm here right now. I go back one step, I get to this place, and when I specify this, it's actually retrieving the values from here, and I will be able to pass those values right here as variables, dependency.ghrrepo, and then outputs the same value that I had exposed here, and then I'll be able to say use this as input. Back to the terminal and apply again, but before doing that, I will need to reapply this stack because I didn't have this output before. Okay, back to the terminal, ghrrepo, just plan, no changes, just one output, just apply. Alright, back again, just plan. Excellent. There's gonna be 2 new resources to add, one output, and these are the resources. K3D config local file, as well as the null resource to create a Kubernetes cluster. Just apply. Excellent. I have my Kubernetes cluster. I can query it with Kubernetes get node. As you can see, I have my Kubernetes ready, age 15 seconds, and there's one node only. That's the server. I will be able to say get pod and kube system, and as you can see, there are a bunch of items being created at the moment: core DNS, Helm install, local path, and metric server. This is it for our Kubernetes cluster. Let's get to the next step. Okay, here we are again. A spin up Kubernetes cluster has been done successfully. We have pointed our issuer URL to GitHub Pages. We can query that real quick. So in the terminal, if I say kube get raw, and yeah, I have it already on my history. As you can see, I can query this API on the API server directly using the raw flag. I will say I'm gonna need well-known OpenID configuration and pipe it to YQ, which is like JQ for YAML files, and print it. So let's see how this goes. As you can see, the issuer URL has been successfully modified on the API server. It is the exact value that I passed to it in the K3D config file, as well as a JW cause URI. So these are the values, and if I query these values, there's nothing in there right now because the GitHub Pages does not have these values just yet, and I'm going to create that in the next step. Okay, here we are, and now we are down to like the sexiest event of this video. This is going to be creating a cron job. This is the main event, and this is what this whole video is all about. Like all these other stacks over here, these are just trying to help this one. What I want to do right now is to grab my Kubernetes OpenID configuration and publish them as to the public repository that I've created earlier, and use GitHub Pages to serve them as static files. And with that, every OpenID Connect supported service provider will be able to trust my cluster if I configure it, and that allows me to have OIDC and pass credentials and whatnot. But let's get to it and create this one. This is the main event of this video. Like if you have not watched anything else so far, this is what it's all about. Okay, back to the editor now. Let's create my Kubernetes OIDC config. The first thing that I'm going to be creating is a versions.tf file, and in this file I will require to have 2 providers. One for required providers, which is going to be Kubernetes, source is, well, of course, HashiCorp Kubernetes version 231, and I'm gonna copy this template and say I'm gonna need customization, of course. This is gonna be KBST customization 0.9. Excellent. I do need to provide my provider config as well, so this is gonna be Kubernetes config path, which is gonna be kubeconfig, as well as config context, which is K3D, K8s. Okay, next, provider customization, which is gonna be the same stuff as before, except that the value are going to be, and the keys are going to be different. Kube config path as well as the context. Crazy confusion here. So here we are. This is the versions file, and now I'm going to be able to pass use this in my stack. So let's just create also variables that I'm going to be using here. One of them is variable GPG private key, and type is a string. It is sensitive, true, and it is not nullable. I'll be using another one just like this one, sensitive and whatnot. GitHub deploy key. Excellent. So the main event, what are we trying to do here? We are trying to create a Kubernetes cron job that will fetch the OpenID configuration of the API server as well as its public key, publish them in the public GitHub repository. As soon as that commit has happened, GitHub Pages will fetch those files and serve them as a static to the internet. And that way I can configure my service providers to trust this OIDC and the pods inside that will also be able to authenticate to my Azure, which we'll get to in a moment. But in a nutshell, I'm just publishing my OIDC configuration of the Kubernetes API server only because my Kubernetes is right now a local host Kubernetes. If I were using a AKS or EKS, they are already having an internet accessible OpenID configuration endpoint, and I didn't have to do that. But since this is K3D, this is local host, I would have to do this all of this manually, which is the reason for all this configuration so far and all this stack so far. Okay, now I'm gonna create my Terragrunt.htcl file. This will be used for me to pass outputs from the earlier stack to this one. So inputs, let's just create an empty block for now, but I will be specifying values here. There's a dependency here. One of them is gh-repo, and the config path is of course one step up, gh-repo. Another one, which I'm not gonna, by the way, write it all the way. There's a dependency again, and the value is GPG key, user GPG key. So that should be it for now, but I will specify the values in a bit. Main.tf file, and now here's the main action and everything that I'll be creating. So the first thing that I'll be creating is Kubernetes. I don't have it just yet. Let me init my stack so that I do have auto completion here. On my terminal, Kubernetes OIDC config, just init. There's a dependency here, and there's a typo actually. Dependency. Same goes for you. Back here again. User GPG key. Here we are, user GPG keys. That's fine, I can just basically remove this. Again, all good. Back here, close all the other ones. Okay, Kubernetes. Let me see if I can get auto completion. Kubernetes config map. this is my first config map metadata. The name is going to be GitHub, namespace is going to be kube system. I will be creating this stack kube system. Data is going to be, well, GitHub repository. The reason that I'm specifying these values as all caps is because these are going to be environment variables, so that's just a convention. Where the GitHub repository, and also commit name, which is going to be, well, just my name, commit email as well, var dot commit email. So let me quickly create these variables right here. Variable, this one, which is of type string, and the default is Kubernetes OIDC configuration. It's actually OpenID configuration. There goes this one, but there's another one of from here. So all good. And now I have this right now. Let's create a secret resource, Kubernetes secret. The name is this. There's going to be metadata, name is GitHub again, namespace is going to be same as before. Data, which is a GPG private key, var GPG private key, and of course GitHub deploy key, which is going to be var GitHub deploy key. And the type of this secret is going to be opaque, which is by default opaque if I'm not mistaken. So there goes that one, and I will create more basically, but yeah, this is it for now. Let me pass these values from my Terragrunt right here. So there's going to be GPG private key, which requires dependency of GPG key that outputs. If I head over to my outputs right here, there is an output here that I can use. Dot this one, and same goes for the deploy key, of course. So let me see what is the variable that I need to specify. GitHub deploy key, apply it here, dependency dot gh repo dot outputs, fetch the exact same value that I have outputted here, which is deploy private key, and that's it. So let's apply this stack and see how it goes. All right, in the terminal, just plan 2 new resources to add, one GitHub secret in kube system, as well as a config map with the name GitHub in kube system. Should be good, just apply. 2 new resources added, and now let's create the masterpiece of this stack. Here we are. I'm gonna create a directory of manifests. So this will be my customization that I'll be creating. So let's just quickly go through this. Okay. I do have this value right here. This is a long one, but I'm gonna go through this and explain the important parts of this cron job. So there's going to be a cron job which is going to be created in the kube system namespace, but I'm not allowing any concurrency on this. Only leave one history if it's failed. Closing this briefly, the schedule is going to be like every 5 minutes, and only one successful history of the job. So this is the spec of the cron job, but let's see the spec of the job. If I open this, you're going to see that there's going to be 80 lines of code here. Backoff limit 1, completion 1, parallelism 1. So basically I just want one pod at a time to run, and that's basically the main requirement here. I don't want contention. So there's going to be one container only, The command is a main.sh, which I'll be writing in a bit. I'm getting the environment variable from the config map I created earlier, right about here. You remember these all caps values? These are the things that I'm passing to my container. The name of it, which is GitHub, it's not optional, and there's gonna be the image Alpine Git, and I'm gonna customize this image in my customization file in a bit, as you'll see. Security key, these are not quite required, but I'm just specifying the values just as I have created my Docker file, which you'll see. But so there's going to be a couple of important volume mounts happening right here. The first one is the GitHub private key. So you remember this one, the secret. There is a GitHub secret here, and the key of GitHub deploy key is going to be used exactly here. So I'm going to use this, mount this into this file, and it's going to be a read-only file basically. So the container cannot touch it. It can only read that. There's going to be also GPG private key, which is using the same secret as before with the GPG private key. As you can see here, I am specifying that from my variables, as well as there's going to be a main.sh, which I'm going to create in a bit. We'll get to that, but there's going to be a GitHub SSH known host, which you can access by just typing GitHub known hosts on the Google, and you will get the results as a bunch of line separated values for different algorithms. This is also read-only. SSH config, this is the part that allows me to specify how I want my pod to communicate to GitHub. I'm gonna write that value as well. This is a config map. And let's see, there's gonna be, I do want the home directory to be mounted as a, read-write directory. So that's the reason for this volume mount. Let's see, there's going to be a bunch of volume definitions that are coming from here. So the GitHub is a secret, and the default mode, as you can see, is 400. I want this to be read-only, but the key and the pass. So the key is the one that I'm passing from here. This is the key from inside the secret. The pass is the pass that volume mount will pick up. So this second pass, which is going to be for me exactly the same, but if I come up, this right here, line 66 on this file, is going to be used exactly as you see in the subpass, line 35, GitHub deploy key. These will be the same. And if I say GitHub deploy key 1, I should come down and modify the path to GitHub deploy key 1. Same goes for the next one. So I do have a key on the secret, which is GPG private key, and the path is going to be like, if I specify this as 2 on here, I do need to go back and specify subpath as 2. So there goes that. There's going to be a config map, which I'll be creating in just about a bit. GitHub known host, SSH config, these are important values, but the main part is right here, that I am actually passing as executable, and it's main.sh, and so that's basically it. And just as before, if you modify the path here, you will have to modify the one on the top. So this is my temp directory, TTL seconds. I want my pod to remain after finish for 1 day, and so that's basically the reason. Saving this file, and so there are a couple of other files in the customization directory that I would like to create. One of them is GitHub known hosts. I already have them here. I'm going to copy them. These are the public key of GitHub, which you can specify right here to enforce your pod to have a strict check on the host. The next one I will be creating is SSH config. SSH config here. So this value is going to be host github.com. I know that the user is going to be Git. I also know that I'm going to be mounting my SSH key into home app user SSH GitHub. If you recall, on the cron job I had a volume mount right here. This is the exact path that I'm specifying my SSH config. Strict host key checking, yes, and user known host file home app user SSH known hosts. These are also specified in the volume right here. Okay, SSH config is done. This can be passed as is into the container. Let's create the next one. So close others here. There's going to be also a customization because I'm going to save the main.sh for the last. That's like the juiciest part of this whole thing. Customization.yaml. All right. So I do have my customization here. It's going to be config map generator. As you can see, I'm using completion. I do have customization extension installed in my VS Code. So config map generator. I have a couple of items that I would like to pass into my config map. Files. One of them is GitHub known hosts. Next is SSH config, and the last is main.sh, which I'll be creating in a bit. But the name of this config map is going to be Kubernetes OIDC. And one thing to mention here is that there's going to be volumes right here. You see the name of this config map is right here, Kubernetes OIDC. The name of the config map, not the name of the volume. These are basically different. So if I specify the name of the volume as 2, I will have to come down here and modify all these as 2, 2, and 2. But this is just the name of the volume specified inside the pod. And this is the name of the cron job configuration, which is actually generated right here. So this has to be identical. And customization will take care of the suffix hash, as we'll see later on. So there's going to be a resources tab attribute here, cronjob.yaml in the same directory. And there's going to be also images. So this is the part that I am using my custom image because I do need some of the tools installed in the final image. This is coming from ghcr.io, developer friendly Alpine Git, and new tag is 2452. So it will take this image, replace it with this repository and with this tag, as we'll see when we build the customization. So there's gonna be, let's just create the common labels for some of the things that we will require. app.kubernetes.io, name is Kubernetes OIDC, as well as instance, as well as managed by, customize, and lastly component, which better be a copy paste of here, component. So that's about it, the labels that I want to specify, but I do want to specify the namespace right here, so it's going to be kube system. And so if I go back to my terminal right now, I will be able to build this stack and see how different components are interacting with each other. Okay, back into my stack, and if I check the current directory, I do have my manifest as you see on the screen, the second line. I can say customize build manifests, and this is gonna go build the stuff. So let me just pipe it to less. Some of these has been unsuccessful. SSH config. Yes, I do not have main.sh. Let's create that right away. That's the main and juiciest part of this configuration. Okay. First things first, there's going to be a shebang involved because this is executable. Set EUX because I do want to see debug information and whatnot. So repo name. There's going to be, I do want to have like an ephemeral dynamic name that I can rely on without having to do crazy string extraction. from my inputs. So this is what it's all about. Repo name is going to be just a timestamp for me, and I'm going to git clone. And you remember those environment variables in the configuration config map that I've been passing around earlier. So GitHub repository repo name and cd into repo name. And this is the reason that I'm using that hard like something that I can rely on, this repo name. Now I can cd inside this, because otherwise I would have had to extract the repository name so that I can cd into it right here. Alright, so this is the juiciest part. I do have kubectl installed inside that image. Get raw OpenID v8 and OpenID. So there's going to be, first of all, I'm going to have to create some of the directories. OpenID v1, and also well known. So these need to be present if it's not already there. And because I do have -p, if it's already there, there's not going to be a complaint here. So OpenID v1 jwcause kubectl get raw well known OpenID configuration into the same as before. So I'm going to create this one as well as this one. So as you can see, these are similar text that I am. So what I'm doing right now, I am grabbing the OpenID configuration as well as the SSH public key. The public key that has been used to sign the service account tokens inside the Kubernetes cluster. And later, I'm gonna, after this line, I'm just gonna push them to the repository. After the push, GitHub Pages will pick it up and serve them as a static file. So, but these are the endpoint that I am calling from the API server. And since this main.sh is going to be a pod running inside the Kubernetes cluster, I don't have to specify the API server URL, because it's already in the cluster. It can already talk to Kubernetes service. And that is basically going to be kubernetes.default.svc cluster.local. So that's the address that it's already aware of. I don't have to do anything about that. So that's basically the reason that I'm not specifying any address here or specifying any kubeconfig, as you would normally usually do, export kubeconfig into some path. So I'm not doing that here because it's already a pod inside the cluster. So next, what I'm gonna do is that I'm just gonna realize, so I do have a CD here, as you can see, into the repository, which means I'm gonna check if these two commands have changed anything inside this repository. And that comes in the form of git status, but in a way that machine can parse that. So this is gonna be if is empty git status porcelain. If it's empty, if nothing has changed after running these two commands, this is going to be an empty string, and this if is going to return true. And if it's true, I want just to say, well, no changes, to commit and exit with 0 fee. Otherwise, if I get to this point, line 24, I know that something has changed, and I need to commit. So that's where the evercursed git add dot comes into play, and I'm gonna have a GPG import. You remember the mount volume here, don't you? There is going to be a GPG key mounted inside my pod that I can copy, and I can paste it right here. And this will mount my GPG key, and now I can specify to my Git 3 important configuration. Git config global user.name is going to be, well, commit name. And this is coming from the config map that I created in my main.sh. Here, commit name, commit email, and we'll get to another one just a bit. Git config global user.email, commit email. And lastly, well, we're not importing this just for the sake of it, right? So I'm gonna do something else. Git config global commit dot GPG sign true. So basically I want to sign my commits with the GPG key provided. Date is your format. This is just a commit message customized to my use case. You can do it as you like. Git commit -m. Well, sure, let's say update Kubernetes public keys. JWK public keys. Yeah, that sounds about right. So when I get down to here, git push origin main, because I already know that the default branch is main, so that's why I'm relying on this value over here. I can get back to my terminal and now build it. Okay, back to terminal again. Last command, run. This time it has been successful. So GitHub known host, a bunch of values hard coded, and I fetched that from GitHub documentation. The main.sh being passed into the configuration as a multi-line string. This is just the syntax of the YAML, nothing to worry about really. And so I get all of these, the same that I have written in my file, but the SSH config file again, a multi-line string right here, right now. And well, these are the labels passed by the customization. As you can see, this suffix hash, as you can see here, is going to be added to M4 and 92. So there's going to be M4, 92. We'll see that in a bit. That is going to be passed inside the cron job. Same label as before into the cron job, into the kube system, namespace. So let's see at the config map. There's a GitHub that I created earlier and it's not optional, but the image, as you can see, has been changed to the one that I specified. So I'm not using alpine/git, I'm using the one that I created by my own because I need some of the binaries installed on that. So these are the volumes that I've been seeing, and so these are just the strings, nothing to worry about. Let's go to the last part here. Kubernetes OIDC M4, just as before, and 92. Okay, I'm back into my terminal, and now I need to specify from inside my TF that I need my customization to be built and applied to the Kubernetes cluster. So I'm gonna close others here, and I'm gonna be using some of the magics inside the Terraform, which allows me to create customization inside Terraform. Here we are. This time I'm gonna be using the customization provider, resource, customization, resource. So this is customization. So this customization build is quite about hectic as it is, and they have a good documentation on why it should be the way it is. But what I'm gonna do right now, I'm gonna just grab them and paste them here. So this has been already applied before, but let's go through this. First, I'm gonna build the customization inside this directory right here. And next, there's gonna be like 3 layers of customization that I need to create here. First, there's the priority 0, the most important stacks, which is coming from the outputs of this here. So there's going to be output on this guy. This is a triplet. The first index is going to be having the highest priority, and the second index is going to be well, after this, which is why I do have a depends on right here. There's a depends on, which is depending on the P0, as you can see right here, P0. Which and the next one is just about the same, except for it has a dependency on P1, right? So I'm not going to go into much detail why that is the case. They have just decided that customization in Terraform has to be written in this way. I'm just using their example code and modifying it to my own use case. As such, I'm not going to go into much detail, but you can read about the documentation online. Let's just go through this and apply this customization and see that my cron job will modify the GitHub repository using the GitHub deploy key with write permission, as well as the GPG key to sign this for that to become a verified commit. So let's go to terminal and apply that. Okay, back into terminal, just plan. two new resources to add. So this is gonna be a cron job definition, as you can see from here. A cron job kube system Kubernetes OIDC, as well as a config map. So this is all coming from the cron job customization. Just apply. Two new resources has been added. Get CM, secret, and cron job in the kube system. So I do have my GitHub, I do have my Kubernetes OIDC, and I also should have secret of Kubernetes, as well as let's see, there's going to be a cron job right here, which is scheduling every 5 minutes, and as soon as this is running, we'll be able to see the result in the GitHub action, in the GitHub repository basically. But before doing that, I do need to specify the GitHub SSH key to my script here. So as you can see, this is not a valid repository. You cannot git clone this. So it's gonna be github.com developer friendly, and then slash the rest of this. So now let's get back to the terminal and apply this stack. Okay, in the terminal, just plan two new to add, just apply, all good. So this change is because of the config map for GitHub repository. Let's see the kube system. We can now go to the browser and see that it has actually committed those values. Okay, in the browser, we are in this repository right now, same repository as before. If I reload this, I'm gonna see a new commit happened right here. All right, verified with the new GPG key, just as you see here right now. So this is gonna be me with the GPG key ID, whatever. But this is the same commit inside the script. And if you go here, you can see just these are the values coming from the Kubernetes API server. These are the same values we have seen when running the same kubectl raw command before. And so I'm commenting them right here. So right now, my Kubernetes cluster is local. It's in my local host machine. There's no internet access to that. But I am still able to create OIDC protocol configuration and integration with other service providers, regardless that there's no internet access to my API server, but it's still able to do that. And as we'll see later in this video, but this is just a true magic here. Like whatever we have built so far, whatever we have done so far, whatever code we have written so far, this is it. This is like the magic. This is the masterpiece of all of this that's happening here. And this right here applies to every Kubernetes cluster, and not just my local K3D. You can use it on AKS, which you really don't have to, because AKS has internet accessible OpenID configuration endpoint. But you can do that if you want to. Kubernetes with kubeadm, minikube, or whatever. So anything is basically possible as long as you can just expose these configuration and public keys to the outside world. So anytime from now on, any service account from inside my Kubernetes cluster mounted in a pod is going to be signed. Its JWT token is going to be signed with the key that this is going to be the public key. So any JWT token inside my cluster will be verifiable with these public keys. And that allows the service providers to check the JWT token against the OIDC configuration and integration that I'm gonna do in a bit with these JW cause public keys basically. And that is the magic of OpenID Connect protocol. So this is the wrap up of this stage of the video. We're gonna go ahead and test and verify if everything we have built so far has been successful. But know this, now from now on, the cron job inside my Kubernetes cluster is going to fetch the new OpenID Connect and JW cause if there is anything new ever happening. So as soon as the key gets rotated or whatever, you're still gonna get those published to GitHub, and you're still gonna have your deployment. So let me go through the deployment real quick. As you can see, I have had the deployment a while ago. This is only a single branch, but I'm still able to access this. So if I copy this URL back into your terminal, if I say curl -s and the same value that I just copied, well-known OpenID configuration, and I'm gonna pipe it to YQ and print it as pretty, but this is GitHub Pages right here, right now. And I can show it to you that it is GitHub Pages by printing everything into the null and just printing the headers. So the server is going to be somewhere around here. Let me see if I can just find it real quick. Server, github.com. So this is GitHub Pages. And you can see that it has like caching mechanism, it has e-tag mechanism, it has all the cool stuff, and it has also HSTS header over here. So I'm not doing anything other than just publishing it to the GitHub, and with the modification, the CI definition, I am able to serve my static files over the internet, and that allows me to establish a trust relationship with other service providers, as you will see shortly. Okay, on to the rest of this agenda. These 4 steps are only here to verify what we have built so far. So there's no more extra feature added here. We're just trying to test out if everything we have built so far is working. We are just going to first create an Azure Vault and a managed identity inside the Azure Resource Manager with a credential. We are going to establish a trust relationship from our Kubernetes cluster to the Azure Key Vault with the OIDC configuration we have just published to GitHub repository earlier. And with that, there's only the rest of this, which is going to be deploying this necessary operator, deploying the external secret operator, annotated with the right values, and fetch a sample value into the Kubernetes from the vault. So let's go ahead and create the Azure Vault right now and the managed identity. Okay, back into editor. I'm going to be creating a Azure Key Vault here, and there's going to be a main.tf right now. Inside the main.tf, I will be using module naming from Azure official Terraform provider. Source is Azure naming Azure RM. I will always and forever find this type of naming very, very strange. So I do find it to be much easier for Azure RM to be before naming. So in an ideal world, I would like it to be, let me just comment this out. My comment is the ideal world, by the way. So this is what I think should be. Azure RM and naming. But this, like, I'm coming from Azure, and then I'm going to Azure RM, and then going back to naming. So this is just quite strange. Anyhow, version, and I'm going to be using this naming, by the way, real quick. Resource Azure RM resource group. This location is going to be Germany West Central, and the name is going to be module naming dot resource group name resource group dot name unique. So let's create the resource group first. We will come back to the rest of it in a bit, but before doing that, versions.tf, and I'm going to create a provider of Azure RM, and I'm going to say I'm not going to need any features, but this is a required block. Okay, back into terminal. Az Key Vault, just init. no Terragrunt file, no problem. Touch Terragrunt.cl. Before applying this stack, I do need to be authenticated to Azure to be able to send requests. So in order to do that, I do have my Azure CLI in my terminal, and with that I have already authenticated. What I need to do now is to instruct the TAF files to fetch the authentication from my Azure CLI. So I will be using dir env over here, which requires me to create envrc file, paste my credentials over here. These are not so much of a credential as much as it is like a instruction to the Azure CLI of which credential to pick up first. There's going to be a tenant ID and a subscription ID, which allows me to just basically use the Azure CLI configuration credential to talk to Azure API. Okay, back to the terminal and let's apply this now. Okay, back into a terminal now. I do need to specify dir env to read those values that I just created. So dir env allow, and this is allowed right now. And if I go ahead and say just plan, right now I'll be able to plan these against my account in Azure. Okay, I'm in my Azure portal right now. As you see, I am on a free trial over here, but that's not the important item here. I should have my resource group somewhere around here. Here it is. This is my resource group, Germany West Central, just as instructed. Okay, now creating the resource group has been successful. Let's create the Azure Key Vault. Back into the editor right now. The next item is going to be resource Azure RM Key Vault, yes, and this is the name of the resource. The name of it is going to be module naming Key Vault, and name unique. Next, location, which is coming from Azure resource group dot location. Resource group name, same as before. This time I'm going to just grab the name. Enabled for disk encryption is true. Tenant ID is going to be a value that I need to fetch as a data. Azure RM client config current. This is coming here, data.azure config, and tenant ID. Soft delete retention days is going to be 60. Purge protection enabled true. Public accessible true. SKU name standard. I'm going to create a network ACL over here. The default action is going to be deny, and the bypass is only for Azure services. But I'm also going to whitelist my own public IP address, which is coming down to here. So I will need to create this first before being able to use it. So this is coming from data HTTP my public IP. This is going to be URL HTTPS check ip.amazon aws.com. And if I come down here, so this is how I will be using the return value of that. Trimming of the spaces because I don't need any blank line at the end. HTTP dot this one, and so this is going to be response body. So everything is by denied. Azure services can bypass that, but my IP address is also publicly whitelisted. Next up, I'm gonna create a policy here. So this is gonna be Azure RM Key Vault access policy. This, and then Key Vault ID, which is gonna be Azure Key Vault .id. Next is going to be tenant ID, data.azurerm tenant ID, and the object ID. So who is allowed to do this? So the access policy is specifying who is allowed to do what, and the what part. So this is basically who is allowed to do what, and it's going to come next. The object ID is of course me, so I'm going to be using the same data as before. This time this is going to be object ID, which is going to be the principal ID of my account on the Azure portal. So the what part is going to be a bunch of resources that I need access to. So I'm just going to grab that real quick from my ready-made terminal. This is it. I'm going to need key permission, key and list. This is the key that is used to encrypt and decrypt. Secrets, I need all these accesses, my public IP address, and there's going to be one last here, a storage permission get, which is not a biggie. I'm just going to allow that anyway. So that will basically allow me to run Azure Vault commands from my terminal, from my IP address. So yeah, that's pretty much the gist of this resource. Let's go to terminal and apply this. Okay, here we are. Just plan. Oh yeah, I'm gonna need to do an init upgrade here. Alright, back into the editor again, and now this time I need output for this stack, and I need some of the items to be present in the output because I'm going to use them. So first there's the resource group name, the location, the Key Vault ID coming from the Azure Key Vault resource, as well as the Vault URI, which is an HTTP form like URL, which I can use later on. Back into the editor and apply it. Excellent. I have the output. Now I can use them later on. Now, back into the agenda again. I have created the Azure Key Vault. There is the manage identity and the credentials left, which I'll be doing that next to my external secret operator stack. So this is just gonna be here for now. We're gonna go ahead and deploy the Azure Workload identity. It's just a Helm installation as far as this goes. So let's go ahead and do that. Okay, back into the editor. This time I'm going to create another stack, and the name is going to be Workload Identity. I will require a versions.tf, and in the versions.tf I'm going to specify Terraform. Well, there's going to be Azure RM. Source is HashiCorp Azure RM. I don't care about the version at the moment, but these should be on required provider. So let's go ahead and do that, as well as Helm. The Helm provider is quite sucky in my opinion. It's just such a lousy provider. They have never provided a robust Helm provider, sadly. Provider Azure RM, but we're gonna use that anyway, and we're gonna complain about it. As well as provider Helm, which is gonna be a Kubernetes actually config path context. Okay, K3D, K8s, as well as config path, which is kubeconfig. Here we are, and so this is our versions file, but we're gonna also need a main.tf over here, a data of Azure RM client config current. So why do we need this? Because in the Azure workload identity deployment, we will need to provide the tenant ID to the workload so that it knows who to sign the tokens for. Azure workload identity repository is going to be https azure github.io/azure workload identity charts. So there's that. There's also chart here, which is workload identity webhook version. So one thing that I really dislike about Helm release provider is that as soon as I provide an X here, like a wildcard for all the patches of the chart version, every time I apply this resource, I'm gonna get a changed on the metadata, which means my resources has changed, even if the latest deployed version is the same as the released chart. So I opened the GitHub issue about half a year ago and it's still in progress. So, you go figure how lousy their job is at providing a robust Helm provider. And I really like the Ansible module for Helm. It's just quite robust. You can rely on it every time. Create namespace true. And there we go. This is like the juicy part of this that we cannot escape. We are gonna pass. Well, we can also set this quite easily. So set name, which is going to be Azure tenant ID, and then there's going to be a value for it, which is coming from data, current, and well, tenant ID, of course. And there's going to be a Terragrunt here, that is CL, which is going to require us to say, well, the input are just empty, so let me just have it as an empty block. But I'm going to have a dependency on the Kubernetes, even though I'm not going to use anything from it. I'm just going to say, unless there's a Kubernetes cluster up and running, I'm not going to be able to run this stack. So that's that. I guess that should be it for us. We can also have an output here. So tf output helm release ID value is helm release this.id. That should do it for us. And that's it. Let's go to the terminal. Okay, all is good. Let's go to the next step. All right, back here again. Deployed the Azure workload identity. It's time to deploy the external secret operator. Alongside that, we'll be creating an Azure managed identity and the credentials. Pass it as pod annotation, tenant ID and client ID, as you'll see later shortly. But the main objective here is that we just want to allow the external secret to fetch the values from Azure Key Vault without passing any client ID and any client secret, and just using the power of OpenID Connect. So let's verify that everything we have written so far is actually working greatly. Okay, back here again. Let's try to write the magic. So this is going to be external secrets. The first file we'll be creating is versions.tf, which is using very similar versions as we had with Azure Workload. So I'm just going to copy paste that. Azure RM, Helm, and so I'm just going to paste it in here. Yes, there's going to be Azure RM, Helm, these two. So there's that. Next, there's going to be an identity.tf. So in this file, we're going to be creating an identity in the same resource group as before, which will allow us to assign that identity to external secret operator to be able to fetch the secrets from Azure Key Vault. Data RM client config current. Next up, it's going to be Azure RM user assigned identity. This the name of it. Well, we can just name it anything basically, but let's just be verbose. Group name. I will need this resource group name in my variables. Type is a string. Nullable is false. Next. I'm gonna need the same. And now let's create the credential for it. Azure RM federated identity credential. Name is going to be external secret. Resource group name, var that resource group name. Audience. This value that I'm just gonna write here right now is something specific to Azure Workload identity. Nothing I am specifying on my own. So if you read their documentation, this is just exactly as it is. You may be able to customize it though, which I don't mind being the way it is. Issuer, rather issuer URL. So I'm gonna need another one of these. Issuer URL. And next is going to be parent ID, which is just the identity we just created earlier, and the subject. This is this subject string that you're going to see here right now is something specific to Kubernetes. So every time a service account is mounted on a pod, they will have this type of pattern in their service account JWT subject claim. This is the namespace, as well as the name of the deployment here. Okay. Lastly, we are going to be creating a policy for it, just as we did for ourselves. Key Vault ID is going to be var.key vault ID, which makes us need one of those. And next is a tenant ID, data, that tenant ID, and the object ID, which this time is going to be actually the managed identity that we have here. Principal ID. Secrets permission. Well, I would like to be able to, from inside my cluster, be able to list and get the secrets. And I do need the certificate permission of get to be able to do that, because I need decode. And after that, there's going to be a Helm release, of course, which means I will be able to copy this Helm release right here, paste it here, close everything else. Let's just deploy the external secrets now. External secrets.io, as well as 0.10. The namespace is going to be external secrets, and I do need a couple of items, so one set is not going to be enough for me. That's why I'm just gonna provide it in this ugly manner that you are gonna see shortly. So it's gonna be EOF. So this is one string that I'm passing here, and I'm gonna pass it as like one Helm, like a Helm value YAML file. So this is the pattern that I'm using right now. Annotations, Azure .workload.identity, client ID. So the client ID is the principal ID, the object ID, or let's say the subject. And the subject is going to be the same identity that we just created a bit before. So it's going to be Azure RM user assigned identity .ds.client ID. I'm gonna need something very similar in tenant ID, which is going to be data.azure RM current and tenant ID. Pod labels. Well, for Azure Workload Identity to be able to mount service account tokens to these pods, this label is actually required. Otherwise, your workloads will not get the benefit of OpenID Connect with the Azure Workload Identity. So we just need to specify this label for every pod that requires the service account for Azure. Next, let's create outputs, which is going to be ID. Not much of an important thing to output, but just something to have anyway. And lastly, there's going to be a Terragrunt. There's going to be a bunch of inputs which I'll specify in just a bit, but first I'm going to need Kubernetes with the config path of Kubernetes cluster. Another one, and actually 4 of these to be precise. So there's going to be Vault, and that's coming from Azure Key Vault. There's going to be one from GH repo, which is coming from GH repo again. And lastly, Azure Workload Identity. Well, we don't specifically need any inputs from that, but we just need it to be present. And in here, I will be able to say issuer URL is going to be dependency.ghrepo.outputs. And if I come down to my GH repo, there is an issuer URL over there. Here, I'm going to just pass it along. Resource group name is going to be dependency outputs vault.outputs resource group name, of course, and something very similar to this one. There's going to be location, and lastly there's going to be a Key Vault ID, which is going to be very similar to the earlier ones. Key Vault ID. Well, that should do it for us for this stack. Let's go to terminal and apply it. Alright, we are back here again. We have deployed the external secret operator, and we have attached the identity of Azure into the pod, which means now they'll be able to fetch the secrets from Key Vault we just created. It's now time for the final stage of our video here to just test if everything is working by creating a secret store and fetching a value using external secret CRD. Alright, down to the final stage. Let's create our final resource in here, which is going to be Vault Secret Store. Creating a versions.tf. I'm going to need Kubernetes, so I just copied my versions.tf from an earlier stack. This is Kubernetes. I have this already, so I can just specify kubeconfig as well as k3d ke8s. Now I need my main.tf in here. Okay, I'm gonna create a Kubernetes manifest. This is gonna be ClusterSecretStore, so CSS. Nothing related to HTML, CSS, obviously. Here we go, API version, external, secrets, IO, v1, beta 1. Kind is cluster secret store, and metadata name is going to be Azure Key Vault spec provider Azure Key Vault, and auth type is going to be workload identity. Vault URL is going to be var vault URL, which I'm going to create in a bit. Okay, so what you see here right now on the screen, the workload identity, surprisingly, using the power of OpenID Connect, I do not have to specify any client ID, client secret, nor any service principal, or its credential, certificate, or whatever. I'm just adding an annotation to the pod of external secret, and even that is something that I'm not doing. The Azure Workload Identity is taking care of that. So all I am doing is establishing a trust relationship between my cluster and the Azure, specifying who is allowed to fetch an identity, and assign the identity to the right pod. And after that, everything is just magic. So what happens here is that there is no credentials here. This ClusterSecretStore is able to operate on its own, not because there is credentials from me being provided to the pod, but because it's able to assume those roles and whatever behind the scene using the OpenID Connect, and it's just able to fetch the secret. So we'll see that in a bit after we apply this stack. There's going to be a variable here coming from Vault, which I'm going to require my Vault output. So here we are, inputs as well as dependency, Vault, config path, Azure Key Vault, and now I do have an output here of Key Vault URI. So I'll be providing to dependency dot vault dot output and this value, and there is a value that I'm expecting on this side, and that is vault URL, which is going to sit right here. And that's it. Let's apply this. So there has been an issue with my ClusterSecretStore, and that is because the indentation here is not right. This has to come one to the left, and now it should be right. Excellent. Now let's try to see if I have my ClusterSecretStore configured correctly. As you can see, this has been created just a while ago, and it is valid, and it can read and write, which is just bluffing, by the way. It cannot write because it doesn't have access, but anyway, so it can read, it is ready. Now we are able to test it by storing a secret in our Azure Key Vault and testing it by fetching it from external Key Vault and putting it into our Kubernetes secret. So let's try this out. All right, we are down to the last stage. So in this stage, we are trying to fetch our secret into the cluster by seeing if we can get the values from Vault using the external secret and using OpenID Connect, passing it as a value to the pod. So let's try and see how that goes. Okay, I'm in my editor for one last time. Let's try to say demo secret reader, for example. Not the best name in the world. main.tf I'm going to be creating a locals. Secret name is going to be PG password, Postgres password, and so resource random password gonna be length of 32. I don't want any special. And here we go with the naming again. Azure naming Azure RM, and I'm gonna create a secret right here. Azure RM Vault secret. This name is module.naming.key vault secret.name unique. Value is gonna be random password that result. Key vault ID is gonna be var.key vault ID. I will require this to be present. Type of a string, nullable false. Next, the content type is a password, and the expiration date is gonna be somewhere in the future. I'm not sure how far away in the future this video is gonna be seen, but you're probably not gonna see this after this date. Let's see. It's gonna be 2030, let's say. As well as Kubernetes manifest. Alright, this is where I'm gonna create my external secret. So this is gonna be manifest API version is external secrets.io v1 beta 1. Kind is of course external secret, and there's gonna be a metadata of course here. Name is well, local dot name, secret name. Namespace is gonna be I'm gonna create this in the default namespace. Spec is data, and it's gonna be a remote ref of this one, Azure RM key vault secret dot this dot name. Secret key is well, let's just say this is gonna be PG password because I'm gonna pass it as environment variable, and there's gonna be a refresh interval of, let's say, from 1 hour here. Interval, I missed an R here. SREs ref, which is gonna be the same as we had created earlier. Name is Azure Key Vault, and that is going to depend on our Azure secret. And later on, I'm only gonna need to create a job right now, which will I'm just gonna bring it down from here. This is the job. There's gonna be a name of demo on the job, the label of demo, a busy box, and I'm only gonna echo the password, nothing some fancy. The secret name has to match that of the external secret, and these are all just a configuration for the job. Okay, replace triggered by manifest change. So the external secret changes, this is also gonna change. Let's go ahead and apply these and see how that goes. But before that, I do require Kubernetes, which means I'll be able to grab them from here. Provider Kubernetes. So that should do it. I'm also gonna need to pass some of the variables in here. Dependency on vault. Okay, config path is going to be Azure Key Vault. And so the variable that I had here can be specified as input on dependency vault outputs and well, vault ID. So let's see the value. Okay, and it should be good. Let's try it out. There's also a need for a provider of Azure RM with the features block set to features set to nothing. Yeah, this should do it. Excellent. Now let's try. There has been a successful job. I can say job demo. So as you can see, this is the value. Now that my stack has been successful, I can see the logs of the job. All right, this is the password, BNF ZFIR. Let's check it out in the Azure portal. I'm in my Azure portal right now. I am my RG Ceto, resource group Ceto, and there's going to be a secret, same secret that I just created. Expiration date long after right now. That's the name. This is the version, and we can go ahead and see the value BNF and ZFIR. So that's about it. That's about everything that we have created so far. This long 2-hour video, we have created a GitHub repository. We have created a deploy key with the right permission, which will allow us to store the OpenID configuration as well as the public key of the Kubernetes cluster inside the GitHub repository. We have created a GPG key for us to allow signed commits from inside the pod that is going to store those OpenID configuration files. As soon as the repository gets a new version, it gets a new file, there's going to be a CI definition that will take care of publishing all the static files as GitHub Pages, accessible through the internet. We spun up the Kubernetes cluster and customized the Azure URL. We created a Kubernetes cron job to make sure that, if the public key or the OIDC config has changed from inside the cluster, we have published it to the GitHub repo and ultimately to the GitHub Pages. To test the entire thing out, we have created an Azure Key Vault and the workload identity to take care of assigning the identities to our pods. And then later on, we have deployed the external secret operator, annotated it with the tenant ID and the client ID, and with the OIDC trust relationship we have set up earlier, our external secret was able to talk to Key Vault and fetch values from the secret store, passing it into the Kubernetes cluster with our demo job. And that concludes our video for today. And I hope you have enjoyed and learned something from it. If you do have any question, don't hesitate to reach out, and like, share, and subscribe. That is the only way I know that these videos are useful to you. Thank you so much.